Okay, now we're going to look at finding the area bound between a function and the x-axis. Now remember that the definite integral, the integral from a to b of f of x, actually gave you that cumulative sum of signed areas. Because if you had a function that was positive for some of the values, like here, we have this function's positive for these values, that part of it, the definite integral over that interval, will end up being a positive value. But the part where the area is below the x-axis, the definite integral over that interval is going to be negative. So the definite integral is signed. Okay, it's that net sum of the areas. So if we actually want to find what the area itself is never negative. The area is a space that's enclosed by something, so it's going to be a positive quantity. So if we want to actually find that area, we're going to have to make some adjustments so that we get positive numbers for all the parts of it, and not let the part that's below the x-axis cancel out with the part that's above the x-axis. Okay, so now if we want the unsigned area between the graph here and the x-axis, what we need to do is take the part that would be below the x-axis here, and we're going to do that integral separately. We'll find a definite integral from a to b. Now, if we did a definite integral from a to b of whatever function this is, f of x, we're going to get a negative answer. So what we're going to do then is we're going to just put a negative in there to turn it positive. So we're taking all the values of the function and we're going to make them positive by multiplying by -1, so that we're essentially looking at that function, the negative of that function, and then getting its area. So if you want the positive area there, if you want to calculate that a, make the function negative. So you can multiply through the function by -1 and then just find that definite integral. Now the b here, if we want to find that b, the area b that's shaded here, since that part of the function's above the x-axis, that definite integral will give us a positive value, which will be the area. So this one, we don't need to make any adjustment for the f. We just integrate it from the b to the c, and we'll get a positive quantity for that area. Okay, so now if you want the area between the curve and the x-axis, if the function is positive, greater than or equal to 0, so the part of the graph is above the x-axis, then that area will just be that definite integral from a to b. But if you have an interval where the function is negative or 0, so it's below the x-axis, then what you need to do to get that area is you need to multiply the function by -1 and then find that definite integral. Okay, so I want to find the area bounded by these functions. Y equal to 4 minus x squared. Remember, that's just the parabola minus x squared plus 4. So that's just this parabola right here. Y equals 0 is just our x-axis. You've got to get a picture of these or you're not going to have a chance to get the answer right. So always get a sketch or graph it on your calculators to know what area it is. And then x equals 0, this is just giving you your interval for x. So we're going from x equal to 0 to x equal to 4, and all the x's in between. So here's where the x is 0, and then x equal to 4 is over here. So the area that's totally enclosed there, between where x is 0 and x is 4, and the x-axis and the function y equals 4 minus x squared would be that part. So the A1 and the A2 are the two areas that we're looking for. Now, right now, if we just set up a definite integral and went from 0 to 4, we're probably going to get something close to 0 because the amount above the x-axis would be positive, the amount below would come out negative from the definite integral, and those two would essentially almost cancel each other out. It looks like there may be a little more below, so we may get some little negative number. But if we want to find the area, it's asking me for the area. It's not saying the net area. Net area would be let the positive and negatives kind of cancel each other out. If I want the area, we need to do it as two separate integrals. So what you're going to have to do is you're going to have to do the integral from 0 to whatever place this curve crosses the x-axis. You've got to determine that intersection point. Now that's where this function is crossing the line y equals 0. So that's where this line, or that curve and that line are intersecting. So if you just set them equal to each other, 0 equal to 4 minus x squared, that says that x squared is 4, and that tells me that x is either 2 or negative 2, but this one is where x is 2. Negative 2 would have been over here, and I don't really care about it. It's not between 0 and 4. So I'm going to look at the integral from 0 to 2 of the curve 4 minus x squared. That's going to give me that a1. Because that part of the function is above the x-axis, that will give me that area. Now the second part, to calculate a2, it's below the x-axis. So if I want to calculate that, I'm going to have to multiply the function by negative 1. So I'll have negative 4 minus x squared. And here, the limits of integration, the part that's below the x-axis, is from 2 to 4. Now this would just be the integral from 2 to 4. If I multiply through by negative 1, I'll have negative 4 plus x squared. I'm just going to turn that around so that I don't have to have the negative first. So it'll just be x squared minus 4. So now calculate those two definite integrals separately. The antiderivatives are going to be almost identical. It's just one's the negative of the other. So we're going to have 4x minus x cubed over 3. And I want to evaluate that from 0 to 2. Put 2 in first. I'm going to have 8 minus 8 thirds. And then minus what I get when I put 0 in. I'll get 0. So this is going to come out to be 8 minus 8 thirds. 8 is the same thing as 24 thirds. Minus 8 thirds is going to be 16 thirds. That's the area A1 in the picture. Okay, now let's calculate A2. A2, I want the antiderivative of x squared minus 4, so it's going to be 1/3 x cubed minus 4x, and I want to evaluate that from 2 to 4. Okay, put your 4 in first. I'm going to have 1/3 4 cubed minus 4 times 4. And then minus what I get by plugging in the 2. So minus 1/3 2 cubed minus 4 times 2. So I'm going to have 4 cubed is 64. So 64 thirds minus 16. And then I'm going to have minus 8 thirds minus 8. Now I can get common denominators in two places. What I'm going to do though is I'm going to go ahead and remove my parentheses, and then I can combine the ones that are already thirds. So I'm going to have 64 thirds minus 16 minus 8 thirds plus the 8, distribute that minus 1 through, and then I'm going to have 56 thirds, and then I have minus 8. And the 8 is 24 thirds, so 56 thirds minus 24 thirds comes out to be 32 thirds. And that's your A2. Notice it's positive. That's because we put that extra negative in and it turned it positive. Now, had you just done the 4 minus x squared from 2 to 4, it would have come out to be a negative 32 thirds. So it's okay to do it without the minus sign. Just know that you've got to turn it positive at the end. And you haven't had any area cancel out either. So if I want the total area here that's bound by these two functions, the area is 16 thirds plus 32 thirds, which would be 48 thirds, which is 16. So there's 16 square units between those two areas. And this is just showing you the steps. Okay, I want the area between the graph of y equal x squared minus 2x, the x-axis, and over the interval from minus 1 to 2. First, you've got to draw the picture. Now this, I know this is a parabola, x squared minus 2x. I could find the vertex. It's important to know where the vertex is, but the easiest way for me to graph these usually is to go ahead and get the x-intercepts. I can factor this. That's x times x minus 2 The x-intercepts are at 0 and at 2. That's, I know where it's crossing the x-axis. So 0 and 2. Okay, so it's crossing there. And I know the vertex is right in the middle. So the vertex is at 1, when x is 1. Plug in 1 and you get -1. So I know the vertex will be here at 1, -1, and I know the parabola is going up since the x squared term is positive. Okay. Now I want to find the area between that function, the x-axis, and between where x is -1 and x is 2. Well, x is -1 is over here. X is 2 would be over here. And then I want it, what's between the x-axis and between this function. So what I'm looking for is this piece over here and this piece in here. Okay, so let's find those two separately. I'm going to call this one, black pen sometimes has a problem. I'm just going to give up on it right there. This is going to be A1, and this is going to be A2. So A1 is already above the x-axis, so I don't have to do anything. All I have to do is find the integral. I need to know the x values. Well, the x value starts at -1 and goes to 0. So from -1 to 0, and then the function is x squared minus 2x. That gives me the A1. Okay. The A2, the part below the x-axis, is, because it's below the x-axis, I have to make it positive. So I'm going to make it negative x squared plus 2x. I'm multiplying through the function by -1. And that's going to make it a positive value. So then from 0 to 2 is the interval that area falls between. So now, doing each of these separately, this is going to be 1/3 x to the third minus x squared, and I want to evaluate from -1 to 0. Put 0 into the whole thing, I'm going to get 0. And then minus what I get when I put -1 in, I'm going to get -1/3 minus 1. Okay, so now I'm going to have -4/3, so +4/3. So that's the A1. A2, get the antiderivative, -1/3 x cubed plus x squared, and I'm evaluating that from 0 to 2. Put 2 in, I'm going to have -1/3 times 8 plus 4. That's what I get plugging the 2 in, and then I'm going to have -0 when I plug the 0 in. So I'm going to have -8/3 plus 4, which is 12/3. It's going to be 4/3. Just so happens to be the same amount. Doesn't look like it is. And so now that's the A2. So now if I want the total area from -1 to 2, it'll be 4/3 plus 4/3 is 8/3. So now what would have happened had we used our calculators and found the definite integral from -1 to 2? This is the total area. But had we just found the definite integral of x squared minus 2x from -1 to 2, what would we come up with? Well, because since A1 came out to be 4/3 and A2 came out to be 4/3 and it's below the x-axis, better get 0.